So I'm going to introduce you to the different parts of Spotter here. So I'm starting right now at the top. I have the top plate removed. It's right here. Here's the top plate. It has the GPS antenna attached on top of it. That's very important for the device being able to control its orientation. Um, Normally this would be connected. Right now I have it removed so that you can see the other parts inside of the main body of the drone here. If we look in the center here, we have the what is basically the brain of the entire aircraft, and that is the NASA flight controller V2, and that accepts the inputs from where that outputs to all of these small components right here. These are small circuit boards, and these are ESCs, or electronic speed controllers. And what these do is these control the amount of current going to the motors, which are on the end here. And each one will have the direction of its rotation indicated with an arrow on it. And this is very important because the way that the device works actually is that three of the motors spin one direction and three spin another. And on each of these motors, there's actually a different prop. So there are standard props and pusher props. And the way that the prop is shaped is very important for the device actually being able to provide lift. Um, so yeah, actually the three of them are spinning one way with one type of prop, and three are spinning the other way with another type of prop. Okay, so that's right here. It receives input from the receiver, which I will show in a moment. It's actually mounted to the underside of this plate. Also up here is the Easy OSD controller and GPS, which is right here. This is what sends that data that you'll be able to see on the display over top of the camera, which is also underneath. Right here is the current sensor. This receives power from the main board or from the battery. That comes in right off of this board, which is also a power distribution board. So that's where you see this battery lead right here. This is an XT90 connector. This supplies power to this entire board, which in turn powers up all of the ESCs, the flight controller, and pushes current through this current sensor. That's all there is on top of the device. Now we're going to flip it over and look at the underside. So right now, this is how it'll look when it's configured for flight. The lithium polymer battery is mounted here underneath inside of this bracket. This allows it to be held very still and stable during flight. If we take this out, which is held in place with these Velcro straps here, I just want to make sure these are very tight because the battery falls out during flight. It could either just fall out and leave the drone dead in the air, or it can fall and get tangled up in the props, which will cause it to catch on fire. So if we pull the battery out, underneath it we can see the receiver. You see right here, it says X8R. And underneath that, it's really difficult to see, but underneath it is actually the power management unit for the flight controller, because the flight controller can't actually take the amount of the voltage from the battery. So there's actually a specific component that takes that voltage and converts it down to something that the flight controller can take. Right here is the LED for the flight controller, and this will indicate to anyone on the ground the current status. It is very bright, so you can see it even during the daytime. There's a whole list of the different codes for that particular light listed in the instruction manual for the NASA. Here is the camera right here, and this is a Fat Shark wide-angle camera. It'll point out, you'll be able to see the props at the very edge of the field of view. Right here is the transmitter. It has this specific type of antenna, which is different than the standard antennas. And this is important for transmitting the video signal back. In order to actually change the channel on this, you have to remove some of the plastic here and move these dip switches. Right now, the channel and the second display, or the first display actually, they're set to the same channel. So this doesn't need to be changed currently, but in the future, or if you need to change it to a channel with less interference, that's how you do it. And you can get a better view of the ESCs here, and 3 wires coming off, going to the motor. You'll also note that these arms are numbered from 1 to 6. This number is very important. You can find it both in the software for the NASA as well as in the instructions. If that number does not line up with the number on each speed controller, which if we flip back over here, if you see here, the number that corresponds to it is indicated by the black marks on the brown wire, and the brown wire always has to be facing up here. If that does not all match up between the number here on the arm and the number here, then and the number also on the top of the speed controller, then the device won't fly. Those all have to match. So that's just a quick tour of what's on the drone. Next up, we have the actual controller here, and this is a Tyrannus XD Plus, I believe. Yeah, X9D Plus, and this is what you used, of course, to control the drone. There should be information about controlling the pitch and yaw. In order to put the drone into startup, you have to move both control sticks to one corner, like this. So that'll actually turn on the motors. Of course, you never want to do that with anyone around. You always want to do that while the device is outside. When you first power it on, you can actually set a fail-safe plan for this controller. It's not set right now, though. You first turn it on, it'll give you a description of everything. You can see there the indicator for the different switches. Currently, because the drone doesn't have any extra functions on it, there's no real purpose for most of the switches. One of them, I believe it's this one, but it can be programmed to any of them, does control what mode the flight controller is in. So the flight controller has multiple modes. The instruction manual goes into more detail about that. Here you have your two sticks. Then we have your trim controls here, and you'll need to use these to trim it out. That may change over time. It'll change, of course, depending on what weight is on it. Change depending on the battery. You can navigate through the menu here. This will tell you everything about the controller and how it's programmed. This is also where you go to set up the, actually you hold down here, to go to the configuration panel to pair a new receiver to it. That may be done if you ever need to replace it. There's an extra one here, and you'd have to pair it. In order to pair it, there's instructions online as well. But you hold down the fail-safe button while the device is starting up, and the LED will blink both red and green, and then you can go and pair it inside of the controller itself. The last thing I want to show is the display, and this is where the data will come back from that transmitter I just showed. It's got this sunshade on it. You can pull that off just by pushing it to the top. It also has two of these antenna on them. On the back here, and this actually needs to be fixed up with Velcro. But here is the other battery. This one, of course, is not interchangeable with the one on the device. If used specifically for this remote, it does not last as long either, which is why it's being used in this configuration. And then you plug that in here. The channel select is here. Currently, this doesn't need to be changed, but you can see there what the channel is that it's set to, which matches what's on the transmitter. And that's about it. I will do follow-up videos talking about charging and starting up the device and then flying it. But that's it for just a tour around the different components on board. Of course, you got your basic frame and everything as well. So yeah, there you go.